Hello, my dear friends. This is Esomno of Online Maths, and this lesson is powered by your lesson app. So, in this lesson, we shall talk about the homogeneous equations. Okay. Now, the homogeneous equation came in as a result of the fact that most differential equations are not variable separable. That is, you cannot separate the x from the y in order to take your integration. So, in that case, we use the substitution y equal to vx to make this solvable. Without this substitution, we cannot solve this equation since it is not variable separable. So this is called a homogeneous equation. Okay. Now, in solving homogeneous equation, we usually make this substitution: let y be equal to vx, so that we can differentiate y with respect to x to get the y dx. Because when you get the y dx, you can remove this dy dx and plug in the value for dy dx here into this equation so that we can get rid of this. Okay. So now, since we've made y to be equal to vx, if you take dy dx, be careful here as you take in dy dx. This is product rule because v is multiplying x. You need to be conversant with the product rule of differentiation. So this is product rule. And it is also implicit in the sense that you have another letter here, v and x. So if you differentiate v, anytime you differentiate a letter that is not x here, you must attach the v dx. All right. So now, if I to solve this product rule, to differentiate it, keep v constant, differentiate x. When I differentiate x, I will get 1 plus, keep x constant, and differentiate v. Of course, when you differentiate v, you get 1, but you must attach the v over the x, because anytime you differentiate v, which is not x, you attach the v dx. Review your implicit differentiation so that you understand what I'm talking about here. So you can now see that our dy over dx is equal to v times 1 is v plus x times 1 times dv is x dv all over dx. Now I can remove this dy dx here to put v plus x dv dx. If I do that, I will now have v plus x dv over dx is equal to x squared plus y squared all over xy, right? This is what I'm having at this particular moment. Now, what is the next thing to do here? Remember that y is equal to vx, right? So wherever you see your y, you can now put vx. Since y is equal to vx, we can now have that v plus x dv all over the x is equal to x squared plus, see my y, I will put vx all squared over x again. Seeing y here again, I will still put vx. All right. Now, continuing from here, we shall have v plus x dv all over the x is equal to x squared plus v, this will give us v squared x squared when you raise to the power of 2. So you have v squared x squared all over x times x is x squared v, x squared v. Now from this, you will still notice that x squared is common, so I can factor out x squared. So I'll have v plus x dv dx is equal to x squared into this x squared divided x squared is 1 plus v squared x squared divided by x squared is v squared all over x squared v, right? Without wasting time, x squared will cancel x squared, leaving us behind with v plus x dv dx equal to 1 plus v squared all over v. We are getting there. Remember, we want to solve this given differential equation. Now let me move this v to the right hand side. If I move it to the right hand side, I'll have x dv dx is equal to 1 plus v squared over v minus v, because it is positive here, coming here it becomes negative. You can call it over 1. So that x dv dx becomes, the LCM is v. V divided v is 1. 1 times this will give us 1 plus v squared minus v divided by 1 is v. V times v is v squared. So without wasting time, v squared minus v squared, it has gone, leaving us behind with x dv dx is equal to 1 all over v. That is the stage we are now. You can see that this is almost becoming variable separable, right? It is almost becoming variable separable. Now, we need this v to be with dv so that this x can come to the right hand side. Isn't it? Once x comes to the right hand side, we are done. So let me clean this side for proper continuation. Okay, so to continue solving this now, we have that x dv dx is equal to 1 over v. To make v to come to this side, what am I going to do? I will multiply both sides by v. Okay, to make v come to the left, multiply both sides by v. Multiply both sides by v. Now I want this x to come to this side. You have to divide both sides by x so that the x can come to this side. Divide both sides by x. You see, because in any equation, whatever you do to both sides will not affect it. When I do that, v will cancel v, x will cancel x, leaving me behind with v dv dx is equal to just 1 over x. 1 over x. V dv dx is equal to 1 over x. Now, I can now take the integral of both sides with respect to x, because whatever you do to both sides of an equation will not affect it. I'm integrating with respect to x, so that this cancels out, leaving me behind with integral of v dv is equal to integral of 1 over x dx. You can see that this has been separated properly, right? It has been separated because v is now with v and x is now with x. We can now integrate. If I integrate v, the power is like 1. So it will be v power 1 plus 1 over 1 plus 1 is equal to, whenever I integrate 1 over x with respect to x, you get ln x plus the constant of integration, isn't it? Then this will give us v squared all over 2 is equal to ln x plus c. Remember in the beginning, we had in the beginning that y is equal to vx, right? That was the substitution we made, which means if I make y the subject of the formula here, sorry, v, that my v is supposed to be y all over x. So I can remove this v. We now have that 1 over 2 into seeing v, we put y over x all squared is equal to ln x plus c, right? That will still give us y squared over 2x squared, isn't it? Because 1 times y times raised to the power of 2 is this. X power 2 is x squared times 2 is 2x squared equal to ln x plus c, right? Now we can cross multiply so that 2x squared will times ln x plus c. If that happens, we shall have that y squared is equal to 2x squared multiplied by ln x plus c. And this is just the solution to this differential equation. Do not forget that this lesson is powered by your lesson app. Thank you for viewing and may God bless you. Bye-bye.